Hello everyone, welcome back once again to Nated Engineering. We are still on friction engineering science entry, and today we'll be looking at a question from the question paper that was written on the 17th of November 2016. It's question number 4, and we are going to start from 4.1, which says list one advantage of friction in practice. We have a few of them that we can mention, but they only want one. So I'm going to mention maybe three. Let's say the first one, it enables us to walk. The second one, it allows power transfer using belt drive or clutches. There are many advantages of friction. I'm sure if you have a textbook, you have they are in your textbook. They have listed, they've gave you the disadvantages and the advantages. It's only a matter of remembering one. So we're going to move on to the second question, which says it's 4.2 and says name two disadvantages of friction in practice. Now they are looking for disadvantages. Friction causes heat, which results to a loss of power. Friction, as a result of friction, heat is generated, which result to a loss of power that could have been used in doing exactly what we wanted to do in that particular machine. The other disadvantage could be it causes wear of surfaces, because we are continuously having two surfaces rubbing against each other that cause wear of those surfaces. And we have quite a few. It's only a matter of going to your textbook and finding out exactly what are the disadvantages and advantages of friction. So those are the two that I'm going to list for this question. We move on to the next question. They say, give the definition of angle of rest. Angle of rest is the biggest angle that may be reached between an inclined plane and a horizontal plane before the body starts moving freely down the inclined plane. That is the definition of angle of rest. And then we are going to move on to 4.4, which is the last question. They say, a vehicle with a weight of 6,500 newtons is kept in equilibrium on an incline by means of a pulling force, which is at an angle of 25 to the inclined. The incline form an angle of 35 degrees to the horizontal plane. The coefficient of friction between the surfaces in contact is 0.3. I want you to take this point, to take like I want to read the statement again, because there's something that they are doing with the two angles, which if you do not pay attention, you might find yourself having taken the angle of the slope and put it where the force is applied. Let's read again. They say a vehicle with a weight of 6,500 Newton is kept in equilibrium on an incline by means of a pulling force, which is at an angle of 25. That is the angle of the force. The force is applied at an angle to the incline, and that angle is 25. That is the angle of the force as it is applied at an angle. The incline form an angle of 33. That is the angle of the slope to the horizontal plane. And then the coefficient of friction were given as 0.3. They say determine the minimum supporting force to keep the object in equilibrium. So this is the diagram that they are giving to us. This is 4.4. This is the diagram that they are giving to us. They gave us theta, they gave us alpha. I always use theta for the inclined and alpha for the angle formed by the force, so that I don't get confused. Always I use it like this. It's not a requirement, it's just what I do. And then they gave us the coefficient of friction is 0.3. They gave us weight. Usually they give us mass, and then we have to calculate weight. But in this case, they gave us mg. We know mg is equals to weight. They gave us the value of mg. That is why here I used weight, which is W sine theta. I did not use mg because we have the weight. So this is the diagram. This is what the diagram is going to look like. It's mass of mass m, although we do have the weight. Anyway, they are saying this object, or it's a vehicle, is kept in equilibrium by a force, by means of a pulling force. They did not tell us where this force is pulling. It's possible that the force could be pulling in that direction. It's also a pulling force. The reason why I put the force to pull in that direction is because of the equilibrium part of the statement. They say the vehicle with the weight of that is kept in equilibrium. Remember, when we are having a force, a weight like that, or an object on an incline, there's already a force that is pulling downward. So there can only be the force that is keeping this thing in equilibrium can only be in that direction. You can't say a force is applied in that direction and then tell us that this force is keeping this thing in this block or this vehicle in equilibrium. It's not possible because there's already a force pulling in that direction. Remember, equilibrium is the state where forces that are going to opposite sides are balanced. So there's already a force that is pulling down. The force that's going to balance must be trying to pull it up. That is why I said our force is going up. I don't know if you understood me there, but I am going to continue. We have the force going up, trying to pull this block vertical, like up the slope, and is at an angle, meaning it will develop two components. And as a result of this force pulling in that direction, we have W sine theta. We have like frictional force in that direction going down the slope. We know W sine theta is always in that direction. We have the normal reaction, we have the component which is perpendicular. Those are the forces that we always have. And then from here, we are asked to calculate for the value of F. So what's going to happen is we are going to start by saying the forces, equating the forces that are parallel to the plane that we're working with. We are going to get what? F cos alpha is going up against W sine theta and frictional force. And then from here we have everything. Because we are looking for this, we have cos alpha, W sine theta we have, except for this, which is frictional force. We know frictional force is given by mu normal reaction times normal reaction. We have mu, we do not have the normal reaction, but we know normal reaction, we can equate the forces that are perpendicular to the plane, which will give us the normal reaction is going to the same direction with F sine alpha, and the force that is going to the opposite direction is W cos theta. We want this as the subject of the formula, therefore we're going to say normal reaction is equals to W cos theta minus F sine alpha. And then from here, we are going to say our frictional force is equals to mu in bracket. We put in the space of normal reaction, we put W cos theta minus 4F sine alpha. And then I no longer need this. move this up. In the space of the frictional force here, we're going to have F cos alpha is equals to W sine theta plus, in the space of frictional force we put this, mu in bracket W cos theta minus F sine alpha. We open the bracket here, it will be F cos alpha is equals to W sine theta plus, open bracket, mu W cos theta minus mu, and it's F sine alpha. And then from here we want this term to be on the same side of the equal sign with this term, because we want to factor out the F which we are looking for. We want to take F common. Then we will end up with something like this: F cos alpha positive mu F sine alpha is equals to W sine theta plus mu times W cos theta. And then from here, let me erase. Let's move this upward. I no longer need this diagram, so I can erase it. Move this up. From here, we are going to factor out F, giving us cos alpha plus mu sine alpha is equals to W sine theta plus mu W cos theta. Make F the subject of the formula here. We have W sine theta plus mu W cos theta divided by cos alpha plus mu sine alpha. And then we do the substitution. Move this up and substitute. W 6500 sine theta 35 plus mu 0.3, W 6500 cos theta is 35, cos alpha is what? 25 plus mu 0.3 rather, sine alpha 25. And then the answer that I got here is equals to 5.155 kilo newtons. I got it in newtons because it was big. I converted it to kilonewton. So that is basically going to be the end of our video. There's something I want to point out. let's erase this. Let's say you are given a diagram like this. A force that is applied in this manner at an angle of alpha, says force F, is the same force that is applied in this manner. So if they give you a force that is applied in this manner, to save yourself a headache, just take this force, put it like this, and continue with life the way we know it. Because you know this force will have two impact on this diagram. We'll be sliding it down, and it will have this impact of pushing it towards the surface plane. What about this force? Same thing. It will have this impact on the block, and it will have the impact of pushing it towards the surface plane, telling us that the horizontal component and the vertical component will be the same. Therefore, these two forces are the same. So don't get confused. If ever for some reason you get something like this, just if it's here, take it from here and put it here, continue with life as we know it. And from there, we are going to end the video. I will see you on the next one.